Problems on work and energy. Problem. A boy weighing 40 kg carries a box weighing 20 kg to the top of a building 15 meter high in 25 seconds. Calculate the power. Now to calculate power, we need the energy. So the power is energy by time. So power is energy by time. Now in this case, we need to find the energy. Now energy is work done. Now work done is force into distance. Now force is mg, which is mass into acceleration due to gravity. So here the mass is the boy's weight plus what he is carrying. So the mass here is weight of the boy plus weight of the box. Hence this becomes 40 plus 20, which is 60 kg. So from this we can find force, which is 60 into acceleration due to gravity is 10. So 600, and we can find out the work done. So work done is equal to the force 600 into 600 Newton. 600 into the distance S, which is given as 15 meters, which will become 9000 joules. So the work done or energy consumed by the man is 9000 joules. So from this we can find power, which is 9000 joules by the time taken is given as 25 seconds. So this 25 seconds, since it is in joules, we will just take it as seconds itself. So when you divide it, we get 360 watts. So the power is 360 watts. So we find out first the power equation, energy by time, and energy is nothing but work done. So in the work done equation is F into S. So we find the force. For the force, since man is carrying the weight and it will come, the total weight is the mass. So we find out the force, and then on substitution we get power as 360 watts. Problem. The following data was obtained for a body of mass 1 kg dropped from a height of 5 meter. Distance above the ground and velocity is given at various distances. At 5 meters, 0 meter per second, 3.2 meter, 6 meter per second, and 0 meter, 10 meter per second. Show by calculation that the above data verifies the law of conservation of energy, where G is 10 meter per second square. What he means is, at each instance of the time, then the energy remains the same. The total energy of the system remains the same. That is what law of conservation of energy shows. So let's see what exactly the problem means. There is a mass of 1 kg and it is dropped, and G is 10 meter per second square, and at 5 meter, that is on top, the velocity is 0 meter per second square. And at 3.2 meter, the velocity is 6 meter per second. And at 0 meter, the velocity is 10 meter per second. That is just before hitting the ground. So let's see from this data how we can prove conservation of energy. At 5 meter, we will see at different distances what is the energy. Now at 5 meter, since velocity is 0 meter per second, we have only potential energy, because kinetic energy is half mv square and v is 0 there. So potential energy, which is mgh, and m is 1, g is 10, and h is 5. So that is 50 joules. Now at 3.2 meter, we have both potential energy and kinetic energy. So in this case, potential energy is mgh, m is 1 and g is 10 and h is at 3.2. So this is 32 joules, and kinetic energy is half mv square, and half into m is 1, and v at this point is 6. So 6 into 6, 2 3s, which is 18 joules. So at 3.2 meters, the total energy is potential energy plus kinetic energy, which is 32 plus 18, 50 joules. Now at 0 meter, we will not have potential energy since height is 0 meter. So mgh becomes 0. So kinetic energy alone we will be having. So kinetic energy, which is half mv square, which is half into m is 1 and v is 10 into 10, 2 5s, which is 50 joules. So now when we see at 5 meter, the energy is 50 joules. At 3.2 meters, the energy is 50 joules. And at 0 meter also, it is 50 joules. So from these calculations, we say that the total energy at various heights is the same. Hence, law of conservation is satisfied. So, it satisfies law of conservation of energy.